Okay. We'll talk about inverse functions. There's a definition of inverse functions. A little more to it. You got to worry about domains and stuff. But just cutting to the main essence, and then we worry about finer points. And I'll probably leave the finer points for you to worry about in your course, since we might not have time to go over them. At least not today. Trying to give you a good start on the section. Okay. And if questions come up, of course, come in Tuesday and we'll talk about it. Okay. That's what we're here for. Okay. So f and g are inverses if f of g of x equals g of f of x equals x. This means you plug x into the f of g of x function and it spits out x. Because whatever g of x does to the function does to x, f of x would undo it. So if this is the case, if f of g of x equals x, it means you get whatever you put in here. So whatever g of x does, f of x undoes it. Okay? So I can actually maybe write that. F and G undo each other. Whatever you start with, G does something, F undoes it and brings you back to what you started with. And similarly, whatever F of X does, G undoes it and brings you back to what you started with. Okay. An example, F of G of X, F of X equals square root of X, G of X equals X squared. We say that f of g of x would be square root of g of x, replacing x in the definition of f of x with g of x, which is a square root of x squared. Now there's a little complication here because the square root of x squared isn't necessarily x. Like, if x is -3, what's x squared? It's 9. What's the square root of 9? It's 3, not -3. Okay? So let's just avoid that possibility by assuming that x is greater than or equal to 0. There are things you do with that when you choose a branch of the function, do the inverse and stuff, but we're not going to talk about that right now. And square root of x squared equals x as long as x is positive, not negative, okay? And then what's g of f of x? Well, that's g of square root of x, which equals the square of the square root of x which is just x. And of course, x automatically has to be greater than or equal to 0 in order to do f of x, right? In order to do the square root. So a restriction x greater than or equal to 0 is necessary here. And we used it here because otherwise this doesn't necessarily come out. Okay, so we see that the square and the square root undo each other. Of course, if you use the squares and square roots, you know that take 5. 5 squared is 25. And the square root of 25 is 5. Because the square and the square root are inverse functions. You want to think through that. Make sure you understand that. Another way of looking at this, if I have a table, standard values I use in graphing these toolkit functions, are these. Geometry is one of my basic toolkit functions. The square root I regard as the inverse of squaring function. Now, we're not going to use the negative values here because we've already said we're going to restrict ourselves to x values that are greater than or equal to 0. Since x is greater than or equal to 0, we cross out these negative values. But then x squared is going to take the values 0, 1/4, 1, and 4. And not only am I writing way down toward the bottom of the board where you can't see anything, we're probably inside the watermark, so let's fix this a little bit and move this over. So here's our table for the squaring function when x is greater than or equal to 0. And we can plot those points and get the graph. We see it's a nice capital parabola. To get the table for the inverse function, g inverse of x, we switch the columns. So we put down here 0, 1/4, 1, 4. Put the y values in the x column and put the x values in the y column. Okay. So we switch the x and the y to get the inverse function. Turns out that the values of the inverse function here are the values of square root of x. Square root of 0 is 0. Square root of 1/4 is 1/2. Square root of 1 is 1. Square root of 4 is 2. So that the inverse function, g inverse of x, equals this f of x function, square root of x. As long as, again, x is positive, not negative. Now, let's see what I've got for space here. Let's use this slide. Okay. On a graph. Okay, here's a graph. Let's say this graph is y equals f of x. And we're not talking about the square root of x and the x squared function anymore. It's any old function f of x. Pick a point on this graph. Let's say this point is -1. get the inverse function. Now, from what I just showed you, we reverse the x and the y coordinates. And 3, -1 is going to be on the graph of f inverse. That means we come over here to 3 on the x. And down here it's -1. And we get this point. And these 2 points are connected. And we don't actually connect them. It's not actually a line. It's drawn a double arrow here. It shows that these points correspond to one another. One being on the graph of f of x, the other being on the graph of the inverse function. And again, that's just like you take the table. If -1, 3 is on the table for f of x, then when you reverse the columns, 3, -1 is going to be on the table for g of x. Okay, well, similarly, we can estimate the coordinates of a number of other points. Let's estimate the coordinates of this. It looks like it's, well, actually, let's go here right above 3. It looks like it's 3, 4, maybe. That means if we come out to 4, 3, so here's the point 4, 3. These 2 points correspond. Okay. This point up here would correspond to a point that you could estimate. This point over here would correspond to a point on the y-axis about here. And if you sketch the graph, you see that this graph is kind of a mirror image of this one. And at halfway between these graphs, well, I didn't get exactly halfway, but this is a line, y equals x. The line y equals x goes right through the middle of these 2 graphs. Every point on this graph goes straight across this line to a point on this graph. Now, that's something you'll want to digest. I'm saying that kind of quickly, but these are important images that you're going to see. Okay? Important idea. Okay, well, the other thing you need to know about inverse functions. We get the inverse of this function f of x equals 3x plus y. Okay, well, x, y is on the graph of f of x. If and only if, those equivalently, we say that y equals 3x plus 5. So, how do we know how to figure out whether x lies on the graph of the inverse function? Well, you're X coordinate up here becomes your Y coordinate, and your Y coordinate becomes your X coordinate. Go back to what we did with the table. We switched the X and the Y coordinates. So instead of Y equals 3X plus 5, we get X equals 3Y plus 5. And that's comes from switching X and Y. All right. To get the function, solve for Y. Okay, well, X equals 3Y plus 5, so X minus 5 equals 3Y. So Y equals X minus 5 over 3. And we then say that F inverse of X equals X minus 5 over 3. We want to verify that F of F inverse of X equals X. And also that F inverse of F of X equals X. And I'll leave that one to you, but it comes out pretty easily either way. Okay, so F of F inverse of X equals, well, F of X is 3X plus 5. So we're going to substitute F inverse of X for X. We're going to get 3 F inverse of X plus 5. And that equals 3 times, well, F inverse of X is X minus 5 over 3. Plus 5. Okay. Now that's a straightforward substitution. You're good with that a little while ago, so I think you're going to be fine with that. If you think we're going kind of fast right now, and that gives you a chance to totally digest this, you have this video for reference, and at least you'll have seen it. So when you see it in a day or two, probably this afternoon, probably in the next hour, okay, you recognize it. When we multiply 3 by X minus 5 over 3, we get X minus 5, and then plus 5, and that just equals X. So we verified that F of F inverse of X equals X. Now, you want to verify, we don't have room to do it. Probably writing within the watermark. Verify that F inverse of F of X equals X. That completes your verification. You actually have the inverse function. Okay? Okay, very good. Hopefully that's going to be helpful to you.